So let's complete the square by warming up. And what we're going to do is we're going to take something in the form x squared plus bx, and we're going to add a constant to create a perfect square. And by the way, I'm just going to say this is not math. And I'm saying that this is not math because we're really going to forget one critical rule, temporarily anyways, that whenever we deal with an expression, if we add something to the expression, we need to subtract it. In other words, we need to keep the value of the expression the same. So if you have an expression, x plus 1, you cannot arbitrarily add 7, for example. So what I'm going to do is I'm going to complete the square. Now, what I'm going to do is I'm going to recognize that this middle term is 8. I'm going to take that middle term and I'm going to divide it by 2. So I'm going to take 8, I'm going to divide it by 2, and then I'm going to square it. So that moves along. So 4, and don't forget to square it. I'm going to work within the brackets. Simplify it. 4 squared is 16. So the constant that I would add here is 16. So now I have completed the square. I'm going to write down the perfect square factor. So if we factor x squared plus 8x plus 16, and that factors into x plus 4 squared. Now keep in mind that if x squared plus 2ax plus a squared, that's a perfect square. If we want to create a perfect square factor, and we factor that creates the factor x plus a squared. So really, if I'm trying to figure out the square, I need to take my coefficient in front of the x, divide it by 2, and then square it. So here, I'm going to complete the square. So I take this middle coefficient, -8, I divide it by 2, and then I square it. Working within the brackets, that's -4 squared, and that's 16. So I'm going to add 16. So that is a perfect square. So, and if you factor it out, it does factor into x minus 4 squared. All right, let's move on. If we want to complete the square, that is, at the end, we want it to create when factored, we want it to be a binomial squared. So now I have x squared minus 6x plus some number, and that will be a perfect square. So I'm going to create it by taking that middle term, -6. I'm going to divide that by 2. And I'm going to work inside the brackets, so that's -3 squared. -3 squared is 9. So I need to add 9. And in fact, that creates, if you factor that creates that perfect square factor that is x minus 3. So far, so good, I think. So when I have, moving on to the next example right here, x squared plus 13x. Well, this is not all that intuitive anymore. This is a fraction. So I'm going to take this middle number. I don't change my process. Take that middle number. I'm going to divide that number by 2. I'm going to square it. So taking that middle number, dividing by 2, and I square it, well, I need to square 13 over 2. But rather than jumping to a decimal, I'm going to square the top. 13 times 13 is 169. The denominator is 4. So the constant that I would add is 169 over 4. And if you factor this is going to factor into x plus 13 over 2 squared. And it may be helpful that we recall what a perfect square trinomial looks like. That's what it looks like. Now, the constant term is a perfect square. How did you get that? Well, you took the coefficient in front of the x and you divided it by 2, then you squared. But when you factor it, it factors into x plus a squared. In other words, what was that number that you squared? That creates the constant in the binomial factor. All right, now how does this differ from the previous one? Okay, yikes. Well, how does this differ? Well, the coefficient is 2. I cannot do this because that coefficient is 2. Okay, moving on. Well, the coefficient here, I could rewrite this as 1/2 x squared plus 2x. Well, here, the coefficient is 1/2. I'm going to choose not to do it. And it's essentially, for the sake of this lesson, anytime that we come across a perfect square trinomial, our coefficients were always 1. Even when I completed the square here, my coefficients were 1. These two examples, I want to say, stop. If your coefficient in front of your x squared is not 1, then you have to make other changes to your equation. But let's get on to the serious business of completing the square.